Morning, guys. Mr. Patterson checking in with another video for IB Math SL. In this section, we're taking a look at 23D Part 3, the mean and standard deviation of a binomial distribution. If we were in class, we'd go through and I'd have you guys work through this, this investigation here for a binomial random variable with n equals 30 and probably success being 0.25. But in this case, we're not going to do that, but I'm just going to have you think about what would happen here if the p were to change from 0.1 to 0.25 to 0.5 to 0.7, and if the n were to change from 10 to 30 to 50, how would that affect the mean and the standard deviation? Which we know we can get the mean and standard deviation doing one var stats. That's something that we saw way back in chapter 20. So basically here, if we were to do this, what we would end up finding is that the mean, I'm just going to skip ahead, the mean of the random variable x is mu equals n times p, that's mu for mean, and the standard deviation of x is sigma, that's the standard deviation of the population notation, is equal to the square root of n times p times 1 minus p. And we know variance is the same thing as standard deviation squared, so that's why it takes the notation sigma squared, and basically it's just going to take the same thing as the standard deviation, it's just going to get rid of the square root. So the variance is n times p times 1 minus p. And again, x is distributed as a binomial distribution with parameters n and p. All right, so once we know that, then we can go ahead and use those formulas to find the mean and standard deviation of particular outcomes. So this example here says a fair die is rolled 12 times, and x is the number of sixes that could result. Find the mean and standard deviation for the distribution of x. So in this particular situation, we want to know what is n and what is p. So since we are rolling the die 12 times, that means n is 12, and p, the probability of success, well, how often do we expect to get a 6? 1 out of 6 times. So therefore, we say this is a binomial distribution with n equals 12, p equals 1/6, so x is distributed as a binomial distribution, 12, 1/6. So therefore, just plugging in, the mean, mu, is equal to n times p. 12 times 1/6 is 2. So we expect a 6 to be rolled 2 times. And the standard deviation, square root of n times p times 1 minus p, is approximately 1.291. So the standard deviation is 1.291. Another example says 5% of a batch of batteries are defective. A random sample of 80 batteries is taken with replacement. So we're putting them back in. Therefore, we have independence there. Therefore, that condition of a binomial distribution is met. Find the mean and standard deviation of the number of defective batteries in the sample. Okay, so n is going to be 80, and p is that 0.05 because it's 5% of them are defective. So we say x is the number of defective batteries, therefore x is distributed as a binomial distribution where n equals 80 and p equals 1/20th, 0.05, same thing. So again, we're just plugging in the mean, mu equals n times p, that's 4, and the standard deviation, square root of n times p times 1 minus p, is about 1.949. That's it for this lesson, a nice quick one here for your assignment. I'd like you guys to work on page 625, numbers 1 through 4. Have a great day.